So what we are going to do now is we're going to shift and talk for a while about hazardous waste, which is, of the programs that you are going to have to deal with, probably the biggest single program in the sense that it touches the most areas across the campus. It is probably, relatively speaking, the most complex just in the sense that it parses through all kinds of different situations, and we're going to talk a lot about different circumstances and what applies under different circumstances. So it's much more detail-oriented than, say, lead paint or asbestos in a lot of ways. And the other big complication is that, as we talked about earlier today, it involves areas that are outside of the control of the EHS facilities staff. So for a number of reasons, it is probably the single biggest challenge that most campuses have to deal with. It's not that it's the most important or that it is the only program, but unfortunately, because of the breadth of the areas that it covers and because of the number of different locations and types of situations that you have to deal with, it's probably the single most detail-oriented program that we're going to cover. So we're going to spend a good chunk of the afternoon on it. And just to go over kind of how the afternoon will play out, what we're going to do is we're going to spend about an hour, a little more than an hour on this, take a quick break, and then spend some more time on this. And then to get the blood flowing, because I know that the afternoon can be a tough time, especially sitting around indoors, we're going to actually get up and do a mock inspection together of a couple of locations across the campus. And so after we spend some time together in the room here, we're going to get up, take a look at a lab, take a look at a storage area, and have you actually do an inspection, and then come back and talk about what you saw. And then we'll come back, and then we're going to finish up with universal waste, which is a special subset of the hazardous waste regulations. So with that, we're going to talk for a while about hazardous waste. And if you flip over, I'm looking, everything that I'm talking about now is under tab 6 in your book. And again, you've got a PowerPoint presentation, and then behind that, you've got a standard auditing procedure and some checklists that we're going to use later this afternoon. So hazardous waste, we're going to talk a little bit about what it is, how you identify it, and what some of the different regulations are. And we're going to constantly be trying to sort things out into different piles or buckets, if you will. When does it apply? When does it not apply? If it applies, which circumstance do you have? Which smaller bucket do you want to keep putting each particular situation into to make sure you're complying with the right set of requirements? So very quick overview. What is hazardous waste, or RCRA, which is the Resource Conservation and Recovery Act? And it's known by RCRA as a quick acronym, RCRA. It's always talking about the regulation of solid and hazardous waste, and also regulation of the storage of petroleum, which, although it's covered under this regulation, we're actually breaking it out and spending a module on it tomorrow, I think, or the next day. So that'll be covered, but separately from what we're going to talk about this afternoon. What we're constantly going to be talking about is you're going to be dealing with trash, waste, something that is no longer needed. Sometimes it's going to be considered to be solid waste, which is just a general term for things that are safe enough to throw out in a landfill that are not generally having to be regulated, as opposed to hazardous waste, which are things that are considered to be dangerous enough. They have to be handled in an appropriate way. They have to be labeled and stored in an appropriate way. And when you ship them off campus, they have to be shipped off in a particular way that is considered to be safe. So we're going to be constantly distinguishing between those. The regulations overall talk about the generation of waste, how it's managed, how it's treated, how it's stored, how it's transported, and how it's disposed. So it's considered to be what's called a cradle-to-grave program, meaning it's all the way from the very beginning all the way to the very end. At each step along the way, there are requirements that need to be met. We touched earlier today about the issue of the EPA and the states and the fact that there is sometimes joint authority over particular situations. The hazardous waste program is one of those. Each state, if it has an appropriately authorized program, has been delegated to oversee and enforce the same EPA regulations. The EPA has the authority to enforce under the state program as well, as long as the state program and the EPA program are largely the same. So in Georgia, the programs are almost identical, and so both the EPA and EPD can enforce each other's regulations. And I know that question came up earlier today as to when does one enforce and when does not. The only time you would have the EPA not enforcing state regulations, especially in the hazardous waste program, is if the state, which is allowed to go above and beyond the EPA, does that in a way that it incorporates a whole section of issues that the EPA has no jurisdiction over. Doesn't exist in Georgia, but in Massachusetts, for example, the state took the EPA definition of hazardous waste and included oil in the program, petroleum in the program. The EPA does not regulate petroleum as a waste. So gas stations are not regulated under the EPA hazardous waste program. They're regulated under the underground storage tank program and other programs, but under hazardous waste, petroleum is not considered a hazardous waste. But in Massachusetts, it is. Massachusetts can enforce against gas stations. The EPA cannot, okay, because that's an area that the EPA has no authority over. However, in Massachusetts, what the state says is that you can be required to keep records of certain things that the EPA does not require you to keep records of. We're going to talk later about storage of hazardous waste in laboratories. Under the federal regulations, you don't have to keep a record of your inspections. In Massachusetts, you do. That's considered to be enough of a similar situation that the EPA can require anybody that they inspect against to measure up to the Massachusetts standards in Massachusetts. So it goes state by state as to what the differences and the similarities are. That's as much as you need to know. If it's confusing, I can talk about it with you later offline. The key thing to know is that there is this joint authority, and that in Georgia, because the regulations are virtually identical, both the EPA and EPD have joint authority over what gets looked at. This is just a quick review of where the different state regulations are set out, and they virtually mirror the EPA's. So with that, we're going to talk a little bit about the first key issue, which is we're talking about hazardous waste. That's what the whole program is really geared to. Well, what is a hazardous waste? Wow, good question, everybody. What is a hazardous waste? Well, here are the definitions. A waste, first of all, before you get to hazardous waste, what is a waste at all? A waste is any discarded material, anything that you are throwing out or no longer need, except for those things that are excluded from what is defined as a hazardous waste. And what is a discarded material? Well, a discarded material is anything that's been abandoned, no longer needed, anything that's been recycled, or something that is inherently waste-like. So it's a fairly broad, fairly vague definition. And this is one of the challenges that hazardous waste regulations pose, both to auditors and to everyone who's trying to stay in compliance, because it's not a clear, bright line. And we're going to spend a lot of time early this afternoon talking about what is a waste, what exactly does it mean, and what kinds of things fall into that category. So with that, I'm going to put a pop quiz to you. These are not in your handouts. These are just 2 slides that I inserted because they didn't photocopy very well. But I'm just going to ask for a quick show of hands. Taking a look at this container, do you think that's waste? Quick show of hands. Who thinks that it's waste? Okay, there's no right or wrong. I'll tell you the answer in a minute, but who thinks that it's waste? How about the middle container? Could be. Okay, and how about the last one, these fluorescent bulbs that are in the corner? Okay, good question. So here's the quick answer. The fact is that for anything that you look at, especially as you go around and take a look at an audit, but as you're also trying to deal with your own campuses, the first thing about trying to figure out whether something is a waste or not is whether or not someone has an ongoing use for that substance, that container, that product. It may be good product, but if nobody has used it in quite a while and no one has the future use of it in the near term, it's probably going to be a waste, meaning someone does not need it anymore. So one of the key things to know is that you can have a product that has a useful life to somebody, but if it doesn't have a useful life to somebody on the campus in the relatively near term, then it is considered to be a waste. The issue comes up a lot in labs where you've got people who stockpile chemicals for 15, 20, 30 years. If they have an ongoing use for them, that's perfectly fine. You can hold them forever. However, if you audit and you ask somebody in a lab whether or not they intend to use this product anymore, and they say, no, we've stopped using that because we've shifted our research, we no longer do that line of research anymore, at that point, it may be a good, valid product. They have no use for it. They have to make arrangements to move it out. The general question is, what do you do when you've got something that appears to have gone past its shelf life, that's been noted down or officially written down somewhere? It's definitely an issue. It's an ongoing struggle. The fact is that at the end of the day, my general rule is, within reason, I will defer to the faculty. If they believe, if they can tell me with a straight face that it is still useful and they have an ongoing use for it, whether they use it tomorrow or a year from now, or they just want to hold it because 3 years from now they probably will use it, that's probably good enough. It's a gray area. It is definitely a challenge. The issue will come up more when they will say, you know what, I have no intended use for this. I just want to hold on to it because I'm a stockpile person. I'm a pack rat. I like to hang on to things. That's definitely, it's an ongoing issue. And that's where it is a challenge to deal with this situation. The reason I'm going through this in some detail is because A, it is very much a gray area. It's not a fine, bright line, but on balance, a regulator will often look at a situation where it looks like it's gone past its shelf life, either what's noted on the bottle or noted in the books, and they will be likely to challenge that. The school, the professor is free to push back and to challenge it and say, no, it's not, it's still a valid product, but it begins to get into a murky area and you begin to get into a bit of a tug of war back and forth between the school and the EPA or EPD. So it's definitely an ongoing issue. The reason I put these three up in particular is because there's a common phrase that you oftentimes are looking for when you are out auditing. You're looking for products that are either crusty, rusty, or dusty, okay? Meaning you're looking for things that look like they haven't been used in some time. It's a lot easier to make the argument that something is a valid, useful product, even if it's 20 years old, if it looks like it has been moved and touched and used sometime in the past. If it has been sitting to the point where it's got a fine layer of dust on it that's a good 1/4 of an inch thick, or it looks pretty crusty and it looks like it's really not being stored in an appropriate way, then you begin to, it looks much more like it's been abandoned. It looks much more like it is a waste. So it's not a fine, bright line, but you're looking to see which way you tend to lean toward for the most part as you're doing your audits. And these are all red flags that at least make you want to question it much more. And oftentimes, in fact, you will get an answer that somebody has in fact has not used it in a good long time and has no future use for it. So this is very much waste-like, right? Okay, and it can be in a lab, it can be in a facilities area, it can be just stockpiled in the corner of a building, and these are typical examples that you will find in virtually any campus across the country. Okay, how about these? Same questions. How about the first one over here? Who thinks this may be a waste? It says no good on it. Yeah, in case you can't read it clearly, it says no good on it. Who thinks that may be a waste? Okay. How about these collection of bottles in a lab? Who thinks that may be a waste? Yeah, it looks a little bit questionable perhaps. All right, and how about the last container over? This is a flammable storage cabinet. Okay, all right. Well, yeah, all right. Here's, these I put up there because they're more questionable in terms of whether or not they're actually waste. What you will find a lot of times in a lab are people who have written something like no good on it. That may be no good as in it's contaminated and it needs to be thrown out. It may be that it means no good as in it's not valid for my experiment that I did yesterday, but it is still of use to me in a different way. So the fact that it says no good on it is an indication that you want to certainly question it more, but it's not absolutely clear that it is a waste. But it's certainly sending up a big flag that says pay attention, question about this much further. But the fact that it says no good on it doesn't automatically mean it's a waste, but it's a good indication to think about it a lot more. Same thing with a lot of these bottles, the fact that they may be looking a little bit rusty or dirty or unused for quite a while. It's a flag, but it doesn't mean automatically that they're waste. But again, it's just something to look for. This actually, these are supposedly very good, useful solvents that are just being stockpiled. The fact that there are so many of them is a bit of a risk, but it doesn't mean that they're waste. However, it does you do want to look at these much more carefully and just ask the question. The reason, again, that I put these up, it's not a trick, it's not to say that you're right or wrong, but these are just situations that you absolutely want to zero in on further. Talk to people in a lab and try to understand better what they're doing, why they're using it, why they've got so many of these, why they need so many of them. It's inviting further conversation. And that's a lot of what the initial stages of Rick are going to focus in on, is trying to get a better sense of what's going on, how these are being used, if they're still being used, and if not, then trying to move them out. All the time recognizing the point that you made, which is it can be a real challenge sometimes. And at the end of the day, my belief is we are here to help serve the institutions as best we can. If a faculty member says they have a use for it, then they have a use for it. And that's where you come out. Just recognize that it is a bit of a gray area, and you're trying to help the school stay out of the danger zone as much as you can. So that's really the main point I wanted everyone to take away from this. All right, so we've now thought about whether or not something is a waste or is a useful product. We now want to talk a little bit about whether or not, when you're talking about what is among the things that are wastes, if we've made a decision that something is no longer useful, is it a solid waste? Is it something that's safe enough to throw in the trash, pour down the sink? Or is it a hazardous waste? Is it something that has to be regulated? And here, some of the things that you want to be thinking about is that the EPA recognizes that there are a multitude of chemicals and hazards that are out there. There is no one way to figure out for all of them what the situation is that would be appropriate. So what they allow you to do is you can sample and analyze the waste using a couple of EPA-approved methods, or applying knowledge of the composition of the material and the process that was used. And here you generally would look to, in the academic world, look to the faculty, look to the research staff to help you if you've got questions about what it is in the lab in particular that you're looking at, to try to understand if it's safe enough to throw in the trash, pour down the sink, or that it needs to be handled as a hazardous waste. In the end, obviously, I'm not saying you abdicate responsibility to the faculty, but I would look to them as much as possible as a partner in this to try to help you understand what it is, because oftentimes they'll have a better sense of what it is than anybody in this room will. So that's what the regulations ask you to think about. There are very loosely speaking, not loosely speaking, there are two types of waste, and we're going to talk a lot about having determined that something may or may not be a hazardous waste. We're going to spend a fair amount of time in the next little bit talking about two types of hazardous wastes. One is called characteristic, and the other is called listed. Characteristic just means, and we're going to walk through this, there are 4 types of characteristics. If a waste meets one of those 4, then it's going to be put in the pile of hazardous waste. If it falls below the threshold for each of those, then it's safe enough to handle as not hazardous, non-hazardous. There are some hazardous wastes that are considered to be inherently dangerous enough that the EPA has put out a list and designated these substances as being on a list. If what you're dealing with is on the list, you're automatically in the bucket that says it's a hazardous waste. It's got to be handled as a hazardous waste. So we're going to spend a little bit of time trying to figure out and understand which bucket we're talking about. Is it not hazardous at all? That's bucket number 1. If it's hazardous, which are the 2 sub-buckets it might fall into? Is it hazardous because it's characteristic, or is it hazardous because it's listed? And the reason we're going to go through that is because if something is listed, then you're set, meaning there's nothing you can do. It's automatically a hazardous waste. If it's a characteristic waste, then you've got to check to see if it really measures up and meets the characteristics. Sometimes it may start out that way, but change. And so if it stops being if it stops exhibiting those characteristics, then you're safe. You can handle it as a not hazardous waste. And all this is geared towards the fact that if something is hazardous, it calls for much tighter scrutiny as to how you're handling it, how you're labeling it, how you're disposing of it. So we're going to go through all this with an eye towards understanding what the requirements are and what the obligations are that go along with this. So, the other thing just to know is that there are waste codes. If something is a hazardous waste, as you ship it off campus, there's a designated standard way of identifying what the waste is. There are manifests that have to track every shipment of hazardous waste, and for each item that's on the manifest, there has to be a corresponding code for identifying what the particular type of substance is. So you just want to become familiar with those. Again, this is an open book thing. You don't have to memorize these, but it helps to be familiar what the terms are and what to be looking for and thinking about. So we're going to spend a little time thinking about characteristic waste. In the universe of items that are out there, there are 4 characteristics. Something can be ignitable, something can be corrosive, something can be reactive, or it can be toxic. So it can burn, It can create an acid burn, it might react and create an explosion, or it might be poisonous. I can remember these. Okay? Again, it's an open book test. TRIC, T-R-I-C. Another good acronym for remembering those. Okay? So as we go through, we're going to talk a little bit about each of these four. Again, the whole point of this is so that as you're walking around the campus, you're taking a look in a lab, you're taking a look in a facilities area. What are you looking for? What are you thinking about? You're looking to see if some of these might be present. And if they are they being handled properly? First one, ignitable hazards. That's the little code that goes with it. By definition, these are items that have a flash point of 140 degrees Fahrenheit or 60 degrees Celsius or less. Items that could spontaneously combust, compress gases, including aerosol cans. So look for aerosol cans, and you will see those a fair amount. Also oxidizers. This is going to be the single largest volume and number of issues. Of all the things we talk about, this is probably the single most commonly occurring type of waste across a campus. Quick show of hands. Who has seen an aerosol can in a trash can? Okay. We're going to talk about this in a little bit, but yes, very common issue across a lot of campuses. Here are some types of ignitables. Things, solvents, oil paints, to the extent campuses use oil paints, stains, partially full aerosol cans, and some acids. So those are typical things that you will be looking for as you walk across a campus. Thinking about aerosol cans in particular, because it's a very common issue. If you have an empty aerosol can, what do you have? All you have is a metal cylinder. That's safe to throw in the trash. However, if there is something still left in there, it can either be the product or the propellant. The product itself may be hazardous. Even if the product is not, most likely the propellant is flammable. So for both of those reasons, you want to pay careful attention to aerosol cans if they have anything left in them. It can be just pressure from the propellant, or it can be the product. You want to make sure that the can is completely empty before it is put in the regular trash. The minute it's completely empty, then it's a safe, solid, non-hazardous waste. Shifts from the hazardous waste pile to the non-hazardous pile. However, if there's still product in it or propellant in it, you've got to take a look at the contents to see what the product is, and if the propellant is there, most likely it's going to be flammable. Before we go on, just any questions about aerosol cans in particular or about ignitable wastes? Well, if it still has useful material in it, you can continue to use it. If somebody just decides that they've shifted over to a new kind of product and they don't like the old one as much, somebody else on the campus may have use for it. Otherwise, what some campuses do is they've got a can puncturer. You drain out the contents as long as you collect that, and if it's hazardous, you handle that properly, then it's safe to do that. I don't know if other campuses have different methods for dealing with aerosol cans, but that's one that I've seen a number of campuses use. Unfortunately, even though it's out of the control of the EHS office, it's within the umbrella of the campus. And the only thing I can tell you is that you have to do your best to try to work with the student activities or their coordinators, their faculty sponsors if they have them, to get them to understand what their requirements are. I don't think so, but I'm going to turn that over to Dave for just a minute.
Yeah, well, we'll talk about air more tomorrow, but aerosol cans wouldn't ever trip you into a different air permitting category. Traditionally, of all the air requirements that would apply to painting and VOC emissions, aerosol cans tend to be exempt anyway. But in order for the total tonnage to trip you into that category, you'd have to have every single student painting for a long time. So. And I believe the answer is yes. Yes, because of the product that's in it, you should be inventorying that. So shifting over then, the second of the four
characteristic wastes is corrosive wastes, and there's the waste code for corrosive wastes. These, by definition, mean that you've got a pH that's either at 2 or less than 2, or at equal to or greater than 12.5. So we're talking about something that is very basic or very acidic along the pH scale. And some common examples are typical acids, sodium hydroxide, some kinds of boiler treatment chemicals are typical types of corrosives that you may find across a college campus. The key thing here to know, which I touched on very briefly before, is that something may start out as a corrosive waste, but there are certain procedures you are allowed to neutralize the material. And if you neutralize it sufficiently under the proper methods of doing that, it no longer is corrosive. It's no longer on the bottom or the top of the pH scale. It no longer then is considered to be a corrosive waste. So the fact is that it may start out as corrosive, but if it's neutralized effectively through a pretreatment system, then it can be safely handled as a non-hazardous waste. The quick answer is that we're focusing just for the moment on what EPA regulates as a hazardous waste. It can have a pH of 3 or 4 and still be very dangerous, but it is safe enough to be handled as a non-hazardous waste for purposes just of the EPA RCRA regulations. The big thing to remember is that we're only zeroing in at the moment on one set of regulations. The fact that it's exempted out from this one set of regulations doesn't mean that it's safe or it doesn't have to abide by all the other regulations, both environmental and health and safety. We're just narrowing at the moment to just whether or not it has to be handled as a hazardous waste. Well, if it's got a pH of 3, if you're going to put on your narrow blinders for the moment and say from a RCRA point of view, it may be okay, but you've still got to look at whether the POTW and the water regulations would allow you to do that. In fact, you probably are not allowed to pour it down the drain. Okay, so you've got to look at several different sets of regulations, but for purposes of this training, right now, this moment, we're just going to narrowly look at hazardous waste. But please, don't only focus on one regulation at a time, both when you're auditing and when you're thinking about how to handle things for your own campus's point of view. You've got to look at the whole universe of applicable regulations. But in order to train you, we've got to take them one at a time for right now, but you've got to look at all of them to make sure you're handling a situation properly.
Do you have to document when you neutralize hazardous waste?
What you want to do in general is you want to be identifying whether or not you've considered something to be a hazardous waste or not. You have to make a determination.
But you don't have to have it documented and recorded.
Well, what you want to do is you do want to make a determination and record that. So yes, if what you're saying is, I have a waste stream in a lab and it shows a pH of 2, however, it is being neutralized according to the following process, and so by the time it leaves the building, it has now got a pH of 6, then you're documenting how you're disposing, how you're determining that that waste is safe enough to handle as a non-hazardous waste. So absolutely, you do want to have a record of that. So moving on to just the third type of characteristic waste. These are reactive waste. These are things that react violently with water. They may generate a toxic gas, or they may explode. Some examples that you might find on a college campus are cyanides, picric acid, ethyl ethers, sulfides. Typically, this is not going to be common on most college campuses, but they do come up sometimes. So you want to be mindful of them, and you want to be aware of them. Okay, and just some examples of where, if they do come up, they might be typically found. The last category are toxic hazards. These are things that are considered to be poisonous. And what a common term that you want to be familiar with, just in terms of coming up to speed on the regulations, is what is called the toxicity characteristic leaching procedure. This is commonly known as a TCLP test, and it is a way of testing the toxicity of certain materials. Why do you do that? Because it simulates the conditions in a landfill, and then it analyzes to see whether or not, if you were to throw this into a landfill as solid, non-hazardous waste, would it be safe enough to remain in a landfill, or would it pose a problem to the environment? So by putting it through this TCLP test, you're simulating those conditions, and you're able to evaluate whether or not it's safe to be considered a non-hazardous or whether it fails the test, and it's got to be handled as a hazardous waste. Because the EPA does not regulate radioactive waste. Again, it's not that it's not very dangerous, it's not that it's got to be handled in a very safe manner, consistent with the regulations. It's just not subject to EPA regulations, so we're not focusing on them here in this class, we're not focusing in on them for the purposes of this audit. But they are absolutely an issue for the campus, absolutely an issue for you as the campus representatives of schools that are conducting those activities. Just in terms of our audit program, we're not going to focus on radioactive materials for purposes of the audit. If you are dealing with any kind of renovation and you're generating waste from the renovation, typically it may be lead-based paint, you absolutely have to do T-clip or a TCLP test to make sure that you are handling that renovation waste appropriately. And if it fails the test, then you've got to handle it as a hazardous waste. So again, all these regulations can overlap with each other. We talked this morning about asbestos and lead paint. Some of that overlaps with hazardous waste. These are some typical types of hazards and what the regulatory limits are. If you're below the regulatory limits, then you're okay. But if you're above the regulatory limits, then it is considered to be a toxic hazard and it's got to be handled as hazardous waste. Same thing, some more over here. Just typical examples of items that may show up on a college campus and what the thresholds are for having to be concerned and whether or not it's going to be in that bucket that's called hazardous or in the bucket that's going to be non-hazardous. Here we're going to talk for just a minute about how things can fall out and move from hazardous to non-hazardous, and we talked about this under the context of corrosive wastes. If something starts out as a characteristic waste, it may be corrosive to start with, a pH of 2 or less, as long as it's not a listed waste, if it no longer shows that characteristic, it moves from 2 to 4 because it's neutralized. It's no longer considered to be a hazardous waste. And again, we're only talking about RCRA, hazardous waste regulations here. It doesn't mean that it's safe to handle for purposes of all the other regulations, but just in terms of hazardous waste regulations, it moves from being hazardous to non-hazardous. So we're going to shift over now for a little bit and move from talking about characteristic wastes to listed wastes. And again, this is all for the purpose of just getting you quickly comfortable with what you got to think about and look about as you walk around a campus and be focusing in on it. These listed wastes, again, are those items that the EPA and by extension EPD has decided are going to be sufficiently risky, hazardous all by themselves, that you've got to always handle them as a hazardous waste. If it's on the list, then it's a hazard. And there are 4 lists that are out there. What are called F wastes are typically solvent wastes. U wastes are wastes that are unused commercial products. And again, there's a list of them. It's not every single commercial product, but if it's on that designated list, it's called a U waste. A P waste is considered to be an acutely hazardous waste. It's a subset of the U waste. It's unused commercial products, but they are considered to be acutely hazardous. I'm flagging this in particular because in a little while we're going to talk about categories of campuses, whether you are considered to be a large or a small or a conditionally exempt generator. P wastes feature prominently in whether or not you are in each of those categories. So we're going to talk about that a little bit more, but that's one of the 4 lists of wastes. And then there's a 4th one, which are K wastes, which are certain kinds of industrial wastes, and they're just not applicable at college campuses, so we're not going to focus on them, but just know that they are out there. In terms of F wastes, these are solvents. They can be halogenated or non-halogenated solvents. They oftentimes are used for cleaning or for degreasing. And they can be coming from a lab, they can be coming from a facilities shop operation. So they're from a number of different sources and locations across the campus. There are, within the F lists, there are a couple of different types of solvents. So anytime you have a solvent, you just want to get familiar with, and ask the question, or do a little bit of research, take with you the list of F wastes just to see if anything is popping up on that list. All right? Again, you don't have to memorize anything, but just be aware to be ready to ask the question if you're dealing with a solvent, to think about whether or not it's an F-listed waste. All right? One other situation, we've talked a lot about what's in a lab. If you have a solvent-contaminated rag that is saturated, and by saturated that means if you squeeze it, you can get drops of the solvent coming off of the rag, then that is considered to be, and the solvent itself is a listed waste, then that is going to be a hazardous product, and it's got to be handled as a hazardous waste. If it's characteristic, then it still is going to be, if it's going to meet the condition of being flammable, then it's going to still be considered to be a hazardous waste. So this is, all of this is a subset, if you will, of what is a hazardous waste. Just because it's not listed, if it meets the characteristics, it's still going to be a hazardous waste. So I don't want anyone to be confused. You're looking at two different categories of substances. If it's on the list, it's automatically a hazardous waste. If it's not on the list, you still then have to go through and determine if it meets one of the characteristics. If it meets one of those 4 characteristics, then it is still a hazardous waste. It's only if it's not listed and it passes each of those 4 characteristic tests, then it's safe to consider it as non-hazardous and to dispose of in an appropriate manner. Sounds like a great suggestion. However, unfortunately, you run afoul of another requirement, which is that at that point, you are treating them by letting them evaporate. And that is an illegal, impermissible treatment of hazardous waste. If you think back, the whole point of these regulations, big picture, is to try to protect the environment. If everybody were to evaporate all their solvents, yes, you'd be solving one problem, but you'd be creating a different problem by putting all this up into the air. So the regulations prevent you from doing that. They forbid you from doing that by saying that that's an impermissible treatment. That's part of why later when we get to talking about containers, they're supposed to be closed, in part so they don't spill, but in part so they don't evaporate. Okay, so absolutely, please know, you cannot treat by evaporating. That's considered to be impermissible, illegal, inappropriate. Okay, any questions about that? All right. So we're going to talk about the fun ones, the P and the U listed wastes. Again, these are unused commercial products. Okay? And this is only talking about something that is a straight off the shelf, if you will, commercial product. It's something that hasn't been mixed, it hasn't been used. If it's been used, it's no longer a P or a U listed waste. Again, it doesn't make it safe, it just means that it's not on the list. Okay? The P and the U listed wastes are old or unwanted chemicals that have not been used, and they contain only one active ingredient, which is on either of those 2 lists. So this is a fairly complicated situation that you have to parse through step by step. And the whole point is that under certain circumstances, this kicks in. There are other circumstances where the same issue, the same items are out there, they're still hazardous. They may just not fall under this particular situation of the P and the U listed wastes. So if you have a waste that contains more than one active ingredient, then it's no longer a P or U listed waste. It may be an F listed waste. It may be a solvent. It may still have hazardous characteristics. So you may still have to handle it as a hazardous waste. It's just not a P or a U listed waste. And again, I'm walking through this a little bit. I know it's a fairly dense subject to talk about because in a little bit we're going to talk about P listed wastes as part of determining whether or not you fall into certain categories. And it's helpful just to understand what either constitutes a P listed waste or doesn't. But the key thing is it's got to meet those criteria in order to be considered to be a P listed waste. What are some P listed wastes? Well, used to be epinephrine. The EPA has now clarified that. But silver cyanide, sodium azide, potassium cyanide are all examples of P listed wastes that could be on college campuses. Some U-listed wastes, acetone, benzene, formaldehyde. Again, this is only if they're unused and they're being taken out of the lab or out of the facilities area and being readied to be disposed of. Then they would be considered to be a U-listed waste. You can have each of these products in a mixture. The mixture, if it becomes a waste, is still hazardous. It's just not a U-listed waste. Right? So again, I know it's a fairly complicated situation. I'm just focusing on it to help clarify when it may be a U or a P-listed waste as opposed to when it may be some other kind of a waste. Very good question. Yes, it does, because later, as you audit further down the process, it moves from the lab to the main accumulation area where it's going to be held, and then it shows up on a manifest. You're going to be checking just to make sure that it's being handled properly, and especially for P-listed wastes, it's going to matter a lot because something could be designated as a P-listed waste incorrectly, which puts a greater burden on the campus than needs to be there. Or conversely, something that should be a P-listed waste is not being labeled appropriately, and therefore the campus is not meeting its appropriate requirements.
And you don't want to mix these and use in a waste stream?
Well, it's not that you don't want to mix them in the waste stream, it's just that they happen to show up on two different lists. These are considered to be acutely hazardous. These are still hazardous, they're just not considered to be acutely hazardous. It's not that they're incompatible with each other, it's just that these are considered by the EPA to be so hazardous that they're in a special category by themselves. Question?
But Arthur, in thinking of that, if you put P waste into your 55-gallon drum out there, you have 55 gallons of P waste.
Yes, and we're going to get to that in exactly 1 minute, but that's a great question. Thank you. Absolutely right. Okay. Let me talk about that for 1 minute, because that's a great comment. The question was, what if you take a small amount of P-listed waste and you mix it into a 55-gallon drum of regular waste, either solid waste or hazardous waste, but that was not P-listed waste? You then move up in the scheme of how much you have to comply with from regular waste to a P-listed waste. So all of a sudden, you may take a small quart container of P-listed waste, you mix it into a 55-gallon drum, and all of a sudden that entire 55-gallon drum is now P-listed waste. You've got 55 gallons to dispose of as P-waste, as opposed to a lesser threshold of just regular waste or hazardous waste. And the further up you go in that chain, the more expensive it gets, the more burden you've got to comply with. So when in doubt, if at all possible, don't mix waste streams together. Keep them separate, because it will inevitably raise the cost most likely and put a greater burden on the campus.
Didn't you just say that waste that contains more than one active ingredient is not a P or a U waste?
Yes. But
if I...
let me take a good example. If you've got a quart of P waste and you've got a 55-gallon tub of water, and you dump the P waste into the water, why? I don't know, but you just feel like that's a good thing to do. All of a sudden, you now have 55 gallons of P waste that has to be disposed of. All right, I'll actually get to that example in a minute, because we're going to talk about rinsing out containers and what to do with the rinsate from the containers. So if you hold off that thought for 1 minute, let me get to that, because I'll give you a better example. If what's in the container itself has not been used, then that's still U-listed waste. It's what you're talking about is the container that you're trying to dispose of. The fact that you've poured some off and used it, the part that you've poured off is no longer a U-waste. It may be some other kind of hazardous waste, but the part that's in the container itself is still in the original commercial container. That is considered to be a U-waste. If you mix water and P waste, then the entire container becomes P waste. And again, let me hold that thought for just a minute, but it's going to be very important and relevant when we talk about generator status, when we talk about which category the campus falls into in just a couple of minutes. That's part of why we're focusing on this so much. because the EPA puts those P wastes in a very special category, and they place a much higher burden on the campus if you have a threshold of P waste that's above 1 kilogram. So we're going to talk about that in a few minutes, but that's part of the reason for focusing in on this so much. All right? Actually, it's right up here. We can talk about it right now. There it is. How about that? I should look at my own slides. If the campus generates more than 2.2 pounds, which is 1 kilogram of P-listed waste in any month, or if it stores more than 1 kilogram at any time, then the campus gets bumped up to large quantity generator status, which is the highest level of regulation for a campus. So if you otherwise might be small quantity generator or conditionally exempt, and we'll talk about what those are in a few minutes, you've got a lesser burden to meet in terms of being regulated and in terms of auditing. You have to audit fewer things. If you end up with more than 2.2 pounds in any month, or you store more than that amount, you are going to bump up the campus to a higher status, and you're going to place considerably higher burden on the campus of different items that have to be regulated and how you have to regulate them. So mixing 1 quart of P waste into a 55-gallon drum of water all of a sudden will bump you up from having 1 quart to having considerably more than 1 kilogram. And all of a sudden, inadvertently, you have now moved up from a lesser regulation status to a much higher regulated status, and you've bought a lot of headaches that you otherwise wouldn't need to absorb. A P-listed waste is only an item which is unused. So if a person in the chemistry department has a container, sodium azide, they no longer need it, and they want to dispose of it, then you have to handle that. The minute they use it and they mix it into a chemical reaction, it's no longer a P-listed waste because it's now mixed with other items, presumably, and it's shifted from being a P-listed waste to perhaps being another kind of hazardous waste, but it's no longer a P-listed waste. One of the key things to remember with P-listed waste is they have to be unused and in their commercial state. Okay, so that's one very key thing. And at that point, if somebody, most of these are so hazardous that you're not going to have a sizable amount of them typically in any one location. But if somebody needs to get rid of them, they want to dispose of them, then they want to dispose of them. And sometimes you have to absorb the cost of moving up from one status of regulation to another. If that's what happens to the campus, then that's where you have to be. What I'm talking about, though, is when you can avoid having that happen by trying to reduce the amount that you otherwise would have. You don't want to inadvertently bump yourself up from one category to the next when you didn't have to. Sometimes you have to, and that's the price of doing business, if you will. But sometimes you can avoid it, and you always want to try to avoid it if possible.
How about that bottle? And leave pop in it. This is all right.
If you use half the bottle,
Yeah.
and then you want to dispose of the other half, then that might be a P-listed waste. Otherwise, if it's still got a use to it, you don't have to dispose of it. Okay, again, keep in mind, step back for a moment and remember that if something has an active, useful life to it, it's not a waste. You don't ever have to throw something out that has a useful life to it and somebody in the lab wants to keep using it. It's only those situations where someone has no use for it anymore at all. It's common for transporters to overstate the amount of P-waste. What happens there is that if a transporter who's taking off your waste has a container of P-listed waste, it's a quart, they typically will overpack it because that's what they're supposed to do to make sure that it's packed safely before it's transported. They're required to weigh the containers to note the weight on the manifests. Sometimes they weigh just the individual container of just the quart. Sometimes they weigh it after it's been overpacked. And if they weigh it after it's been overpacked, you're absorbing all of that extra weight. And it could put you from having 1 quart, let's pretend it weighs a pound, to an overpacked container that now weighs 6 pounds, which is give or take about 3 kilograms. You've now moved from having considerably less than the 1 kilogram threshold to having more than the 1 kilogram threshold. And so you absolutely have to pay attention to that, both as an auditor and as an auditee. You absolutely, because we've seen this happen many, many times. It absolutely does happen. It doesn't happen every time, but it absolutely does happen sometimes. Yes.
Or are you forever?
No,
there?
you're not there forever. And when we get to the hazardous, when we get to the generator status, let's talk about that. If you want to repeat that question at that time, absolutely. You are not stuck there forever. Okay. Last type of category, real quickly, is used oil. It's within the hazardous waste regulations. And again, we're going to spend a whole module on this, so I just want to flag it to you to know that it is there. But we're going to cover this in another module. This is what we were talking about earlier when we talked about mixing wastes together. If you take a more regulated waste and mix it with a less regulated waste, it becomes more regulated. So a listed waste, which is the highest regulated level, if you mix it with a non-listed waste or a non-hazardous substance, the whole quantity becomes a listed waste. All right, so absolutely, somebody asked that question earlier. Be mindful of this, and whenever possible, don't mix waste streams together, because you're going to increase your cost of disposing of the entire quantity under that higher threshold, the more expensive threshold. Yes, you can, absolutely. The issue, though, is that you may, for example, decide to mix, I'm going to just make this up for the moment, PCB oil with regular waste oil. The minute you do that, everything gets treated as PCB oil, which is considerably more expensive to deal with. So when in doubt, try never to mix any kind of waste streams together that are going to bump you up in terms of how much it's going to cost you to handle them. If they're going to not increase the burden, if they're going to keep the burden the same, then you absolutely can mix them together. As long as somewhere you are keeping a record of what the actual weight of the P-listed waste is, it's very, very important. And at the end of the day, I believe that the transporter works for the school, and you've got to talk to them and explain to them this is going to be, it may be a small headache for them, but it's going to be a large headache for you, and you're not going to accept that. I absolutely agree with you. It is a lot of information to absorb in a fairly short amount of time. And really, what I want you to take away from this is just a general understanding that there are various types of wastes. There are various questions you want to be thinking about. There are various buckets, if you will, of things, and you're trying to figure out which bucket something may go into. More than that, the specifics of what kind of characteristics there are, what kind of listed wastes there are, and what particular situation applies in what area is something that we're going to work on, and slowly you'll absorb over time. When you do the audit, we're going to think through this and talk through this a lot, especially for anybody who's going to be auditing hazardous waste. You're probably going to audit it and shadow one of us for a while first before you do any of that. So keep in mind, it's an open book process. This is not meant to make you an expert today or even over the next 3 days. It's just meant to expose you to some of the concepts and to get you thinking about it. So please don't expect that you're supposed to walk out of here and absorb all this. You can't, and you're not supposed to. You're really supposed to just now be thinking about the fact that there are these questions and these issues, and to be aware that there's material here, there are resources to go to, there are people you can go to for more questions and to think this through. Alex.
I'll add, you've got, I think, 4 sources of information. Everybody in this audience, our office, you have the EPD folks, Billy Hendricks. He will answer questions almost day and night. You also have the consultants while we have them for this 4-year stretch. So, I mean, you've got any one of those number of avenues to get answers. You also have Base Camp, which obviously is this entire group. So I would consider that. And your Billy Hendricks is extremely outgoing and will go to extra lengths to get your question answered. And he is your regulator, so take advantage of his generosity.
Right. Absolutely. What I'm going to try to do is go through the next couple of slides and then I want to take a break. I know we called for a break at 2:15. I'm just going to try to get through the next couple of slides, and then I absolutely want to give everyone a short stretch. There are a handful of situations where something is not a hazardous waste. So just want to acknowledge that. We don't have to spend a lot of time on it. Again, we're trying to think about when the RCRA hazardous waste regulations apply. They don't apply when you send something to a scrap dealer for recycling. So a metal that otherwise might be a hazardous waste, if it's going to be recycled and sent to a scrap dealer, falls out of the regulations. You don't have to worry about it. Universal waste, which is something that we're going to cover at the end of the day today, there are specific set categories of certain kinds of wastes. As long as they're handled properly, they're not hazardous wastes. They are universal wastes. So we'll talk about that later this afternoon. And then ash is not a hazardous waste. And then the last one, which I do want to talk for a minute about, something that is in an empty container is not considered to be a hazardous waste. So what's an empty container? Aha! Lo and behold, how empty is empty? What does it mean to have an empty container? It means that you have tried to pour something out or remove it through scraping it or pouring it or pumping it, and you've got no more than about 1 inch or 3% of the original volume of the container. That's considered to be empty. So it doesn't have to be literally bone dry. It just has to be good enough. So you can have some hazardous waste at the bottom, as long as it's less than that amount, that drops out from the regulation and you don't have to worry about it anymore.
As long as it's not pea waste.
Ah, good question. So, thank you for that. You get a gold star. What if it's pea waste? Well, if something is a pea waste, then it's not considered to be empty unless the container has been triple rinsed. So this is a special situation. Container that has pea waste in it, it's got to be triple rinsed. And this gets to the question earlier about why would you ever mix pea waste with water? Well, if you're triple rinsing it, what are you rinsing it with? Typically, you're rinsing it with water, perhaps. All of the rinsate, the water mixed in with the pea waste, is going to be considered to be pea-listed waste. So it usually does not pay to triple rinse a container, okay? Because you end up with a lot more pea-listed waste than just handling the original contents of the container and throwing that out as pea waste. So it's typically less expensive to dispose of the container as hazardous than it is to manage the rinsate. But just know that that is an option, and that's what you have to do if you want to consider the container to be empty and safe. Question?
There is no volume that EPA gives for how much rinsate you actually use.
Yes, that's true. Right. You do not have a prescribed amount of how much you need to use, but you have to rinse it 3 times, and no matter how little you use, you're going to use a little bit more than the original contents of the container itself. So you will have more material to dispose of. You've got to be very mindful of that kind of a situation because that may also still be considered to be a hazardous waste. Some quick audit or tip questions to be thinking about as we're going around and auditing for this section. And again, you're not supposed to be an expert today, but these are just some suggestions, things to be thinking about as to issues you'd want to be asking about, situations you'd be looking for as you're auditing, trying to look to see what chemicals are used, what wastes are generated. Are things being drain disposed? What's being thrown in the trash? Is anything being evaporated? How are the following chemicals being used? So again, these are just tips and things to be thinking about as you're auditing. These are meant to be triggers for trying to catch situations and think about them. It's not that they're automatically good or bad situation, but rather these are places where you want to ask more questions and be looking and thinking about what's going on. And then these are just some things to be looking for. Again, as you're trying to grapple with whether or not something is a waste or not, whether something is hazardous or not. You're looking to see if something is dirty or rusty or corroded, crusty, rusty, or dusty. You're looking to see if there's stains in the sink. Again, it may be perfectly appropriate, but it's a trigger. It's a question, it's a flag. Aerosol cans in the regular trash, things with heavy metals or solvents in them, open containers in the hood. It may be part of an experiment, which is valid. If it's a waste, it's no longer a valid, acceptable reason to have an open container in a hood. Typically, you want to look in refrigerators just to see what's there, to ask the question. Again, these are just triggers to ask more questions, to think about situations.
Obviously, you're talking about food refrigerators.
I'm not talking about food refrigerators. No, absolutely not. No, no, no. Although I won't question whether or not somebody in their house somewhere may have things that are hazardous. I'm talking about chemical refrigerators here.
Because, I mean, we have samples of refrigerators all the time.
Right. And it's perfectly appropriate. It's more just you want to ask the question and see what's there. That's it. These are just places to ask more questions. It's not to say that there automatically are going to be problems. It's just to say these are places where you want to ask the question and learn more about it as you walk around and as you audit.